previous video we have discussed about the atomic model. That is first one is the J.J. Thomson model, second one is the Rutherford model, that is nuclear model. And also we have studied some concepts of that is electromagnetic radiation, where we came across the words, terms, that is the wavelength, the frequency, wave number. Okay, so using these ideas, now let us go for the next concept of the atomic model, that is known as the Bohr's model of hydrogen atom. So Neil Bohr is a Nobel laureate, got a Nobel Prize for this concept, and he has explained about the hydrogen atom, especially hydrogen atom. So he has given some points that is known as the postulates. So Bohr's model of a hydrogen atom. So as per the Rutherford model, he also explained that the nucleus is at the center, electron revolves around the nucleus in a circular path called an orbit. But he gave some more idea. From his model, he has explained about the radius of an atom. So radius anna now calculate madikagutte. So that is one of the plus point. Okay. Then when electrons are revolving in the circular orbit, they does not lose any energy. As per the Planck's theory, when a charged particle is under acceleration in the movement, it loses energy. So therefore automatically the electron will fall into the nucleus of it. Electron yavaga charged particle ಸುತ್ತಾ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಅದು ತನ್ನ ಶಕ್ತಿಯನ್ನ ಎನರ್ಜಿ ಕಡಿಮೆ ಆಗ್ತಾ ಏನಾಗುತ್ತೆ, ಅದು ಸುತ್ತಾ ಬಂದು ನ್ಯೂಕ್ಲಿಯಸ್ ನಲ್ಲಿ ಬೀಳ್ಬೇಕಂತಿತ್ತು. ಬಟ್ Bohr has mentioned that, Bohr ಏನು ಹೇಳಿದ್ರು, so electron when it in the same orbit, so it does not lose the energy, ಅದೇ orbit ನಲ್ಲಿ ಇದ್ದಾಗ. Okay. Then but by absorbing energy, or it can jump from one orbit to another orbit. So electron ಏನಾಗುತ್ತೆ, ಅದು ಎನರ್ಜಿ ಪಡ್ಕೊಂಡಾಗ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಒಂದು ಆರ್ಬಿಟ್ ದಿಂದ ಲೋವರ್ ಆರ್ಬಿಟ್ ದಿಂದ ಹೈಯರ್ ಎನರ್ಜಿಗೆ ಜಂಪ್ ಆಗುತ್ತೆ. ಸೊ ಎನರ್ಜಿ ಸಿಕ್ಬಿಟ್ಟು ಏನಾಗುತ್ತೆ, ಜಂಪ್ ಆಗುತ್ತೆ. ಸೊ ಅಂಡ್ ದೇ ವಿಲ್ ನಾಟ್ ರಿಮೈನ್ ದೇರ್, ಇಟ್ ವಿಲ್ ಕಮ್ ಬ್ಯಾಕ್. ಸೊ ಇಟ್ ವಿಲ್ ಕಮ್ ಟು ದ ಲೋವರ್ ಎನರ್ಜಿ level. When absorbing energy, it will move to the higher energy, and by releasing that energy, it will come to the lower energy. So there is a transition takes place. One energy dinda another energy ge transition takes place. So during this process, so the energy is lost in the form of a radiation. ಯಾವಾಗ electron ಒಂದು lower energy ದಿಂದ higher energy ಹೋಗುತ್ತೆ, ಅಥವಾ higher energy ದಿಂದ lower energy ಬಂದಾಗ ಎನರ್ಜಿ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಎನರ್ಜಿ ಯಾವ ಫಾರ್ಮ್ ದಲ್ಲಿ ಕಡಿಮೆ ಆಗುತ್ತೆ? It is in the form of a radiation. ವಿಕಿರಣ ಮುಖಾಂತರ ಅದು ಲಾಸ್ ಆಗುತ್ತೆ. So that is a yes mentioned. Then one more point he has given, that is ಎಲ್ಲಿ electron ಕಾಣಲಿಕ್ಕೆ ನಮಗೆ ಚಾನ್ಸಸ್ ಇದೆ? Electrons are possible only in those orbits where its angular momentum, it is in a circular path ಇರೋದ್ರಿಂದ it is having some angular momentum. Where angular momentum is a integral multiple of h by 2pi. So ಎಲ್ಲಾ ಕಡೆ ಎಲೆಕ್ಟ್ರಾನ್ ಕಾಣುವುದಿಲ್ಲ. ಸೊ ನ್ಯೂಕ್ಲಿಯರ್ ಮಾಡೆಲ್ ನಲ್ಲಿ ಹೇಳಿದರು ರುದರ್ಫೋರ್ಡ್, electrons there is large number of gaps in the atoms ದಲ್ಲಿ ಬಹಳಷ್ಟು ಗ್ಯಾಪ್ ಇದೆ. ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗುತ್ತೆ, ಕೆಲವೊಂದು ಸ್ಪೆಸಿಫೈಡ್ ಸ್ಪೇಸ್ ನಲ್ಲಿ ಅಷ್ಟೇ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. So therefore he has mentioned it. Where we can find electron ಎಲ್ಲಿ ಕಾಣಲಿಕ್ಕೆ ಚಾನ್ಸಸ್ ಇದೆ? Where the angular momentum is equal to the integral multiple of h divided by 2pi. ಆ ಕಂಡೀಷನ್ ಎಲ್ಲಿ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗುತ್ತೆ, there we can find the electron. So like this he has mentioned 4 postulates. So that is called as the postulates of Bohr's theory. Postulates. So first one he has given, that is electrons are revolving round the nucleus in a circular path called as a orbit. Electron revolve from the nucleus in a circular path called orbit. That is the first postulate. Then second one, the energy of the electron does not change when it is in the same orbit. Energy of the electron does not change when energy of the electron does not change when it is in the same orbit. Okay. On the same thing, the energy of the electron does not change with the time also. So ಆ electron orbital ಸುತ್ತ ಎಷ್ಟು ಹೊತ್ತು ಬೇಕಾ ಸುತ್ತಲೇ ಅದರ ಎನರ್ಜಿ ಚೇಂಜ್ ಆಗುತ್ತಿಲ್ಲ. Energy of the electron does not change when it is in the same orbit, or energy of the electron does not change in the whatever the time in the same orbit. So but here when an electron jumps from one orbit to another orbit, so there delta E means change in the energy equal to E2 minus E1. So change in the energy possible yavagagute electron will jump from one orbit to another orbit. Okay. And third point, third postulate, the frequency of radiation absorbed ಅಂದ್ರೆ ಎನರ್ಜಿ ಪಡ್ಕೊಳ್ಳೋದು, absorbed or emitted ಅಂದ್ರೆ ಬಿಟ್ಕೊಡುವುದು. The frequency of radiation absorbed or emitted is given by equation. It is nu equal to, frequency is a nu, frequency symbol is nu equal to E2 minus E1 divided by h. E2 minus E1 divided by h. H means what? H is a Planck's constant. Okay, further we are hearing that. Then the fourth concept, fourth postulate, so fourth postulate ಏನು ಹೇಳ್ತದೆ, electron, where we can find the electron can be found only where the angular momentum is given by the formula mass into velocity into radius equal to integral multiple of h by 2 pi. So where we can find the electron, where it's a angular momentum is equal to the integral multiple, n is a integer, okay, and h by 2 pi. So only those, then we can find the electron. Just like I will give example here, when ನಾವು electron ಕಾಣ್ತೇವೆ, just imagine, compare the sports ನಮಗೆ 100 meters running alcohol 200 alcohol 400 alcohol 800 or 1000 ಈ ರೀತಿ ಇರ್ತದೆ. So we are not having any 150 meters track ಇಲ್ಲ. So either you want to go for 100 ಅಲ್ಲಿ ಓಡಬೇಕು, ಇಲ್ಲ 200 meters ಅಲ್ಲಿ ಓಡಬೇಕು. ಸರ್ ನಾ 150 ಓಡ್ತೀನಿ ಅಂದ್ರೆ ಆಗುದಿಲ್ಲ. Same way, electron will revolve around the nucleus, where we can have the this rule. ಇದು satisfy ಆದಲ್ಲಿ electron revolve ಆಗುತ್ತೆ. Okay. So nucleus is at the center. This nucleus. So electron we can find the electron in those orbitals where angular momentum is a integral multiple of h by 2 pi. So electron can be found out only in these orbitals, that circular path. Electron is electricity. So these are the positive charge, that is proton and the neutron, that is called as a nucleus. Electron around the nucleus ಸುತ್ತಾ ಇರ್ತದೆ. ಮಧ್ಯದಲ್ಲಿ electron ಇಲ್ಲ. ಇದಾದ್ಮೇಲೆ next electron orbit ಇದೆ, next orbit. So next ಇಲ್ಲೆಲ್ಲೂ ಕಾಣಲ್ಲ ನಮಗೆ electron. Next ಮತ್ತೆ next ಬರೋದು next orbit ನಲ್ಲಿ ಅಷ್ಟೇ. So those are called as orbit. Okay. So these are the four postulates are given by the Bohr's. Normally Bohr's theory na ಕೇಳ್ತಾರೆ. So example 3 marks explain Bohr's model of hydrogen atom or postulates of a Bohr's theory. Okay. So then he has given some points on this. That is from this postulate we can measure the radius and energy of the hydrogen atom. Okay. Then when a gas is passed, when a hydrogen gas is taken in a discharge tube and the high voltage is applied, so then the transition of the energy, electron can jump from one energy to another energy. Electron one energy to another energy jump out. So next orbit. So he observed that there are 5 spectral lines. So electron jump agi and ಮತ್ತೆ ಅಲ್ಲೇ ಇರಲ್ಲ. electron ಇಲ್ಲಿಂದ jump ಆಗಿದೆ ಅಂದ್ರೆ ಮೇಲೆ ಯಾವುದೇ ಎನರ್ಜಿ ಅಲ್ಲೇ ಇರಲ್ಲ, ಅದು ವಾಪಸ್ ಕೆಳಗಡೆ ಬರುತ್ತೆ. just like when you throw a stone, ಅದು ಕಲ್ ಮೇಲ್ಗಡೆ ಹೋಗಿ ಅಲ್ಲೇ ಇರಲ್ಲ, ಕೆಳಗಡೆ ಬರಬೇಕು. means it want to get a stable, ಕಡಿಮೆ ಎನರ್ಜಿ ಇದ್ದಲ್ಲಿ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. so same way here, electron when it absorbs energy and it will jump to the higher energy level, so it will not remain there, it will come back to the lower energy. It may come here also, here also, here also. That depends upon how much energy it is having. Okay. So based on that, we can find some of the spectral line. We observed 5 spectral line. So that is known as the hydrogen spectrum. And he has named that also. So that is the Lyman series, Balmer series, Paschen series, Beckett series, Full series. So like that, he has explained the hydrogen spectrum. Okay. So let us take about the spectral line of hydrogen atom. Yes. So spectral lines for hydrogen atom. So I have mentioned that when hydrogen gas is taken in the discharge tube. Okay. So hydrogen is having one proton and one electron. So in the discharge tube, when you apply the high voltage, so there is a possibility of jumping, that electron gets some energy and electron moves to the higher energy. So electron is in the ground state. So it may move from here, higher energy. So these are called as the orbit or shell. Okay. So I'll jump on that. So they may not remain there only. So they will come to the lower energy. So based on that, he found that there is a 5 spectral lines. So that is known as the hydrogen spectrum. Spectral lines for a hydrogen. So electron moves to the, so ilide one level inda adu higher energy level hogutte. Yavadu level hogiಲ್ಲ. So if it comes to the from higher energy level, suppose if I take this infinity, from higher energy level if it comes to the lower energy level, that is the first energy, n equal to 1. This is n equal to 1, this is n equal to 2, n equal to 3, n equal to 4, n equal to 5. So higher energy to lower energy. So that is n equal to 1 ಗೆ ಬರಬೇಕು, ಇಲ್ಲಿ 2 ಇರುತ್ತಲ್ಲ. So infinity, the next I have taken n equal to 5, next n equal to 4, then n equal to 3 and n equal to 2. if it comes to like this, means all the energy level ಎಲ್ಲಿಂದೋ ಇರಬಹುದು, it comes to the n equal to 1, so that is called as a Lyman series. Okay. So that is known as a Lyman series. So if electron comes from any of the higher energy level to the n1, that is n equal to 1, that is known as a Lyman series. Next, that is the first spectral line. Next, second one is when it comes from any higher energy level to the second n equal to 2 bandre. So this is n equal to 2 energy level bandre. From higher energy level to n equal to 2. That is called as a Bohr series. So Bohr series ನಲ್ಲಿ this it's a higher energy level, lower energy is n equal to 2. So next is a Paschen series. Paschen series ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, higher energy level to n equal to 3. So from higher energy level it will come to the n equal to 3. So that is known as a Paschen. Paschen series. So similarly, next is a bracket series. So from higher energy level to that is known as a bracket series. Bracket series. So next is from any higher energy level, if it comes to the n equal to 5. So this is known as a PUC series. PM series. P is a silent. Okay. So these are known as the 5 spectral lines of a hydrogen atom. Electron ಏನಾಗುತ್ತೆ, when you take a hydrogen gas in the discharge tube and you apply high voltage, the electrons in the hydrogen gas, so they will jump on to the any of the higher energy level. So when the discharge tube ದಲ್ಲಿ ಖಾಲಿ ಒಂದೇ hydrogen atom ಇರುವುದಿಲ್ಲ, ಬಹಳಷ್ಟು hydrogen atom ಇರ್ತವೆ. Okay. So then when it jumps from the higher energy to the n1 equal to lower energy where n equal to first orbital ಬಂದಿರುತ್ತೆ. So we can get this type of spectral lines, and that is known as the Lyman series. So when if it comes from higher energy and up to n equal to 2 ಬಂದಿದ್ರೆ, so that is called as the Bohr series. This is the visible region. So normally we must know that which is the visible region of a hydrogen spectrum. So Bohr series is a visible region. Okay. So this is a UV region. First one is a UV region. Next is a visible. Next IR. So which series is observed in the ultraviolet region? So yavadu this one, that is the Lyman series first. So which spectral line is observed in the visible region? That is the Bohr series. Next is a Paschen series, where electron moves towards from higher energy to n equal to 3. See, observe here, ಎಲ್ಲರೂ ಇಲ್ಲಿ ಬಂದಿಲ್ಲ. So ಯಾವುದೋ ಬೇರೆ ಬೇರೆ energy ಇಲ್ಲ. See here ಇಲ್ಲಿ, next ಇಲ್ಲಿಂದ ಶುರು ಆಗಿದೆ, ಇಲ್ಲಿಂದ. So it comes to this node. Similarly here also, from infinity next here, from here it comes to this. So you have to observe the lines properly. So like this, we can get there is a 5 series of a spectral line. And when we say the spectrum ಅಥವಾ ಯಾವ ನಮ್ಮ ಬೆಳಕು ಕಂಡಿದೆ ಅಂದ್ರೆ there is a some wavelength, frequency ಇರಬೇಕು. Okay. So therefore we have studied earlier, that is the electromagnetic radiation, where the wavelength, frequency, wave number ಎಲ್ಲ study ಮಾಡಿದ್ವಿ. So he has also given the calculation for the wavelength of this. So this is about the hydrogen spectrum. So now if it is asked for 3 marks, you have to draw this type of diagram and you have to mention the series, Lyman series, Bohr series, Prashad series, bracket series, full series. 5 spectral lines. And the spectral lines, the wavelength is given by the formula. So wavelength is given by the formula. Here it is a wave number. So 1 by lambda. See wavelength and the direct lambda. So here the formula for 1 by lambda equal to Rydberg constant RH into 1 upon n1 square minus 1 upon n2 square. Okay. So what do you mean by this? So this is the lower energy level, this is the higher energy level. So for Lyman series, so this one formula is 1 by lambda. 1 by lambda equal to RH into bracket 1 upon n1 square minus 1 upon n2 square. What is RH? RH is a Rydberg constant. It is having a constant value. Okay. So 1 upon wavelength lambda. So this is also known as a wave number. New bar. So for Lyman series, what is the lower energy? So N1 is what? N1 is a lower energy level. And N2 is a higher energy level. RH is a Rydberg constant. RH is a Rydberg constant. Okay. So now here we can calculate the wavelength for a Lyman series, Bohr series. So what is the N1 and for Lyman series? Always lower energy is 1, and N2 may be 2 ಆಗಬಹುದು, 3 ಆಗಬಹುದು, 4 ಆಗಬಹುದು, 5 ಆಗಬಹುದು, 6 ಆಗಬಹುದು, 7, 8, 9 up to infinity. Okay. So for Lyman series, N1 equal to always a 1. N2 ಎಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ? N2 starts from 2, 3, 4, 5 onwards. Okay. Similarly for Bohr series ಅಂದ್ರೆ ಯಾವುದು? ಅವಾಗ N1 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಾಗುತ್ತೆ? ಲೋವರ್ ಎನರ್ಜಿ ಲೆವೆಲ್ is not 1, it is 2 ಆಗುತ್ತೆ. N1 is a 2. What about N2? N2 may be 3 ಆಗಬಹುದು, 4, 5, 6, 7, 8, 9. Okay, one of the very important formula, that is a 1 by lambda equal to RH, Rydberg constant, its value is